Because hot engine exhaust represents one of the largest sources of infrared emissions from any aircraft, and infrared detection has become increasingly important in modern air defense. For years, the B-21's rear section was one of the most closely guarded secrets in military aviation. During the bomber's public reveal, organizers only showed the front of the aircraft, partially pulling it from the hangar. This wasn't accidental. It was a lesson learned from history. In 1988, during the B-2 Spirit's reveal at the same facility, a photographer rented a Cessna to fly over the ceremony and captured images of the Spirit from above, revealing its exhaust design to the world. The Air Force wasn't about to repeat that mistake. But why is exhaust design such a critical secret? Because hot engine exhaust represents one of the largest sources of infrared emissions from any aircraft, and infrared detection has become increasingly important in modern air defense. When most people think about stealth, they think about radar evasion. But one of the more effective recent methods for detecting stealth aircraft involves infrared search and track sensors, IRST systems. These sensors are passive, meaning they don't emit anything that could reveal their location. They simply detect heat signatures. IRST sensors are small enough to mount on fighter aircraft and relatively inexpensive compared to large air defense radars. They're becoming ubiquitous on modern fighters and increasingly capable of detecting aircraft at significant ranges based purely on thermal signatures. The B-21 counters this threat through sophisticated thermal management. Like the B-2, the Raider has engines buried deep within the airframe. Exhaust is ducted through internal channels before being expelled through flat, slot-like openings. This design accomplishes several critical things. First, it completely shields the hottest parts of the engine, the turbines and combustor, from view, especially from ground-based threats looking upward. Second, it spreads exhaust over a wide, flat area, allowing it to mix with cooler ambient air and reducing its temperature signature. The B-2 uses special materials in these exhaust channels to further cool gases before they exit. The B-21 takes this concept further with advanced geometry and materials developed over the past 30 years. Rather than using the sawtooth trailing edge that the B-2 employs at its exhaust channels, the Raider uses updated geometry and likely incorporates airflow mixing even before the exhaust exits. This manages heat far more efficiently. Consider the advancements in material science and computational fluid dynamics since the 1980s, and you begin to understand how much more sophisticated the B-21's thermal management has become. But the Raider isn't just a flying heat sink. It's been designed for all-spectrum low observability, minimizing signatures across the entire electromagnetic spectrum, including radar, infrared, acoustic, and even visual detection. This represents a huge leap from the B-2, which was primarily designed to defeat Cold War-era Soviet radar systems.